Kevan Carstensen. I'm a backend engineer here at Goat Group, and today I'm here to tell you about Refinery. Refinery being Honeycomb's sampling solution. Just general outline of what I'm talking about. I'll just give some backgrounds on Goat, telling you about our company, our systems, and our observability tooling. Then I'll talk a little bit about sampling in general, like why you would wish to sample, why you might not wish to sample, and why we chose to sample. Then I'll talk specifically about Refinery, mainly about our process of deploying and managing that. And then I'll finally wrap up with some concluding remarks, things that we've learned, things that we'd like to improve about this going forward. So just brief introduction about Goat. So Goat Group represents the leading platforms for authentic sneakers, apparel, and accessories. We operate 3 distinct brands, Goat, Flight Club, and Alias, and we have a global community of over 30 million members across 164 countries. And we are hiring across all technology and non-technology roles. So if you're at all interested in what we do or about what I'm talking about here, do feel free to check out that careers page. So digging into some of our systems, and I will focus on backend systems here, just because for now, that's primarily what we have hooked up to Honeycomb. We have a variety of different tech stacks, but primarily we use either Ruby on Rails or Golang. A lot of our older code lives in Ruby on Rails, primarily in a single monolithic Ruby on Rails application. And a lot of our services, that is our newer backend services, are written in Golang and in more of a microservices pattern. Taken together, that's dozens of different services. Those services deal with a variety of different traffic patterns. So some of them are extremely high volume consumer facing services that our customer facing applications hit to fulfill sales, to deliver content to mobile applications. Kind of on the other end of that, we have services and backend systems that are focused on, say, our warehouses or on a handful of internal stakeholders, and they may do hundreds of requests in a day, maybe even less than that. And there's also a variety of different types of requests. So some of these are REST APIs or gRPC services that are dealing with client traffic directly. Some of them are backend jobs that run in Rescue or in another job system. So there's a good amount of variety there. And similarly, on our team, there's also a good amount of variety. We have engineers kind of running the gamut, both in terms of experience in general and in terms of tenure specifically at Goat. So we have a number of engineers who have just recently graduated college, maybe have not had to think about observability or used very many tools around that. And then at the other end, we have very senior people, more than a decade of experience, deep experience running systems at scale at similar companies. So kind of the tools that we have to, use to keep track of our systems as they run, they need to be comprehensible and usable by all of these engineers, and they need to deliver good insights across these different tech stacks, these different service types, and these different traffic patterns. And we have a variety of tools to help us do that. We use Bugsnag, which is an exception reporting and grouping tool. If you've never used it, it embeds in your application, groups unhandled errors, sends notifications about those errors to PagerDuty, to whatever other tooling you have. We have a number of StatsD and CloudWatch metrics provided by our infrastructure, which tell us things, CPU utilization, memory utilization, the number of containers running for a particular service, the error rates across services, generally very good visibility into kind of metrics that you can observe from the application looking from outside. Getting more into things that come from inside the application, we have kind of a standard Elasticsearch Logstash Kibana pipeline, also some Grafana dashboards that provide us metrics, logs, and some alerting, kind of distinct from StatsD and CloudWatch, and that these tend to come from within the application and can show us metrics that developers have chosen to add to the application. And then finally, we have Honeycomb, which gives us tracing, so the ability to visualize the execution of a single request. We have a number of alerts and SLOs that are keyed off of Honeycomb data. And this is really useful for just visualizing, understanding bottlenecks, and in particular for engineers who are either new to the company, new to the industry, or both. It's a great tool for those folks to learn more about the application, like learn what actually goes on when a certain API is called in a way that's maybe a little bit more approachable or comprehensible than reading through the code. So that's kind of a very high level and breezy introduction to just Goat and our systems and kind of the context in which we're thinking about sampling. Now let's talk about sampling itself. So should I sample? This comes up in the pollinator Slack every so often, and it turns out to be a tricky question to answer. Certainly there are a lot of good reasons why you shouldn't sample, and many best practice documentation out there will tell you don't sample by default. And I think that's a good default for a lot of people because there are a number of downsides with sampling. Just in general, sampling behavior, and this isn't specific to Refinery, this applies to anything that samples metrics coming from your application. It's often surprising and unintuitive. Like if you're investigating an issue that you've been paged for at 3 in the morning, your first thought isn't going to be, gee, are these metrics being sampled? Am I actually seeing the true frequency of how often this problem is happening? So even if you're familiar with sampling, that may not come to mind. And it's more cognitive load that developers have to keep in their heads when understanding a system, as compared to an environment where there's no sampling, when you can just assume if something happened, it is in our data set, I can query over it, it will show up in the counts that I'm looking at from this query. Sampling infrastructure, if sampling is implemented outside of your application, is yet another thing for your team to maintain. This is maybe less of an issue for very large companies who have infrastructure teams who focus on this 100% of the time. I think it's always an issue, like having to maintain things just requires time from people, and no matter how large your organization is, that isn't something you should commit to without thinking about it. For a small company like Goat, that's especially important, where a lot of things like sampling infrastructure, they are owned by people who have a number of other things to do. And, that doesn't mean you shouldn't have sampling infrastructure. That doesn't mean you shouldn't spin up new services, but it is something you should think about before doing it. And then finally, like sampling configuration itself, like the decision of what to sample, how aggressively to sample it. Those decisions are, I'd argue, necessarily backward looking. Like you're looking at past incidents, past traffic patterns, and you're making a decision about what is interesting, what is not interesting, and tuning sampling rules to fit that conclusion. And you may be right a lot of the time, and that may be a good decision for future issues, but there's always a possibility that you'll see an issue that's just really poorly served by the sampling decisions you've made, like events that you didn't even think about when deciding what is interesting, what is not interesting, turn out to be really interesting. And maybe you discover this when you get paged at 3 in the morning and the data that you want to be there aren't there. So, I mean, that's a risk, and it's frankly kind of hard to work around. So it's a pretty substantial downside for sampling. On the other hand, sampling can make sense in some cases. So if you have very high event volume, and this can be just due to a large number of traces or very dense traces, and what I mean by that is traces with a large number of events, or both. Or maybe you have events that are in general 95% of the time uninteresting or irrelevant. Like an example that comes to mind from our application is that we have a good deal of instrumentation on how Rails caches things. And for like the 1 out of 100 incidents where this is important, it's really cool to have it. It helps us visualize, like, is our caching working? Is our caching not working? But it's also incredibly noisy. Like, there are a lot of events that come from these. And in most cases, you know, you're not going to be looking at them. So in that example, like those events, which are very frequently uninteresting, there would be an argument to sample those. Obviously, it's a very complex topic. We're not going to fully cover it in one slide, but those are kind of some pros and cons for sampling. So given all of that, why does Goat sample? And the sort of short answer is that we have a very high event volume. Our higher volume applications can generate 150 million more traces per day that we send to Honeycomb. And a lot of these applications are very well instrumented. Like, we have great visibility into database access, into cache access, and you know, this is great. Like, we can see so much of what's going on in our application when we're looking for issues, but it also means that each trace can have dozens, even hundreds of events. And sending each and every one of these to Honeycomb and having them retained in our data set is just cost prohibitive. So we need to sample. So given that we need to sample, how do we sample? And why should we use Refinery? So Refinery was a good fit for our sample needs for a few reasons. It does trace-aware sampling, which means that a sampling decision will apply to every event within a trace and not just on individual events. If you are sampling with Honeycomb, this, in my view, is the way to do it, because the traces that you do see are effectively the complete traces that your application generated, and you don't have to worry about missing spans or certain types of events that didn't make it into the trace. I know the B-lines offer ways to sample events within a trace. We opted not to explore this just because it's sort of an implication of my earlier point that sampling is unintuitive. Like, if you are sampling at all, having to reason not only about whether a trace makes it to the data set, but whether certain types of events within the trace make it to the data set. Like, it's more cognitive load. It's more likely to cause misunderstandings during issues. And just in general, we preferred trace-aware sampling, and Honeycomb or Refinery offers that. It's also very easy to integrate into our existing applications. They're already using Beeline. Beeline generally makes it easy to just drop in another, rather than having it send events to Honeycomb, send events to Refinery. It's able to handle our event volume requirements, and the sampling options are a good fit for our needs. And we know this because it powered the legacy Refinery product behind the scenes at Honeycomb. And this is something we used for a good long while before it was deprecated. And we know that it worked well for us. So that's, in a nutshell, why Refinery was attractive to us for sampling our Honeycomb event volume. And just briefly talking about deploying, I think this will be different for everyone. Everyone has a different internal infrastructure. Just briefly going over what this was like for us at Goat. So just very briefly, we wanted to adapt Refinery to run on our internal platform as a service, which is maintained by our DevOps team, and then tune it to meet our load requirements. So the first two bullet points are essentially adapting Refinery to run on that platform as a service. We needed to Dockerize it, and we ported our legacy Refinery rules to hosted Refinery. And I think we have a leg up here over a new installation because we had that past experience of using legacy Refinery. And we had a good basic set of sampling rules that we could build off of using our own Refinery. The hard part, and there's a lot of work encapsulated in that third bullet point, was load testing and changing our replication and provisioning parameters for Refinery within our internal platform as a service. So just for context, one of the goals we had for this project was to have Refinery running in our internal infrastructure and having our highest volume event generating applications going through Refinery by holiday season 2020. And we are kind of in the e-commerce space. So essentially after Thanksgiving is our highest traffic period of the year. And not just for Refinery, but as a company, one of the things we do to prepare for that is a load testing initiative. So identifying paths through the application that we think high volume users will take. And this could be a response to promotions, a response to just push notifications, marketing, anything that would drive traffic through our application. And then we have teams that build tools that allow us to load test these paths across all of our different services to identify bottlenecks, understand what our system is capable of delivering, and help us tune and optimize and generally put ourselves in a good place for our holiday season. And we took advantage of this to help tune Refinery. Like, we didn't directly load test Refinery, but we had these applications that were under test send their event volume to our Refinery. And kind of what we were hoping for was to get Refinery provisioned in a way that it could deal with the event volume during these load tests. And since these load tests tend to be representative of what our applications actually see during peak load time, if Refinery can deal with the load that they generate, then it should be fine for production use. And we worked pretty closely with the team that was working on those load tests just to monitor Refinery while they were going on, to deploy configuration changes, provisioning changes, things like that. And we ended up in a pretty good spot at the end of that. And then finally, post that process, so having everything in production running through Refinery, we monitored sample rates, event volume, and other metrics, both in Honeycomb and in our own infrastructure, to just evolve our sampling strategy. So example of this might be looking at the sample rate in usage mode and making sure that it's reasonable. Like, we're sampling at 100% of requests going to Honeycomb, and we're sending a ton of volume through Refinery to get there. Like, that's not good. That's essentially us not sampling at all, and that has cost considerations. So that's an ongoing process. That's something we do even now, even after it's been running for 6 months, just using usage mode, using other tools within Honeycomb to keep an eye on this, to identify gaps, to tune as necessary to plug those. And this is pretty ECS specific, but this is just an idea of where we ended up with that. So we run ECS tasks. Our entire infrastructure for most of our applications is based on these. We gave them 2048 CPU allocation, 2048 memory allocation, and they run on M5 large EC2 containers. And if you're not familiar with ECS, this is, I believe, half of the CPU resources of that M5 large and a good deal less than the total memory of it. There's probably room to tune this. We've been happy enough with these settings to just leave them alone. And then in terms of replication and scaling, we have it configured to do between 15 and 45 running refinery tasks. So would never run fewer than 15, and it would never run more than 45. The former is essentially the amount that would be needed to deal with the load that we would see during a reasonably high volume period. And the latter is the highest we have seen it in testing and that we're confident it would run well at. In practice, it's usually around 15. It very rarely gets above that. We have seen it get up to mid-30s during exceptionally high volume periods, but that's pretty rare. Finally, lessons learned. So what went well? And this first point is the one I'm personally the most happy about since I maintain the service. It's very low maintenance once it's running. So it's stable. It doesn't have issues that require investigation. It just keeps working. I think when writing these slides, it may have been the first time in months that I actually had to take a look at the refinery graphs or the refinery service metrics. So that's a fantastic plus point for a service like this, particularly for a small company like us, where folks that are responsible for these things have a lot of other things to do. Usage mode in Honeycomb and the fact that Refinery has its own data set in Honeycomb by default, those are super helpful for tuning. Like I can see the sample rate very easily. I can see whether Refinery is exhausting some memory buffers or something that maybe points to more provisioning that's needed. Just very helpful, very easy to get visibility into the system as it runs. And rules-based sampling, just given that we have an event quota, having rules that allow us to very precisely indicate the sample rate we want, that's great too, because it lets us get the most of that event quota, and it lets us make sure that, you know, kind of those lower volume endpoints that are meant to serve internal stakeholders that I mentioned earlier, and make sure that we're retaining those at an acceptable rate and they're not getting crowded out of the data set by very high volume consumer facing traffic. Some things that were challenging, there are more sample rule types in Refinery than are documented, which feels like a bad thing to complain about, like why complain about more features? But we did have to read the source code to find these, and I might not have thought to look for them if I hadn't used legacy Refinery previously and known that some of these were exposed in the UI. As mentioned earlier, sampling, that it's a concept and that it's a separate service, that's surprising to engineers. And that's kind of hard to work around. I think the best we can do is just document that that is a thing and help people understand, you know, one, what the sample rates are, and two, where they would go to change them. And then finally, adoption and advocacy for sampling is just an ongoing process within Goat. And we currently have most of our higher volume event generating services going through Refinery. Some of the other ones go directly to Honeycomb still, and it'd be great to have those also go through Refinery. Then just very briefly, since I'm almost out of time, some things that we're hoping to continue to work on. I'd love to have CI style checks for sampling rule configuration, like guarding against people accidentally turning off sampling and sending all of our event volume to Honeycomb. Right now, the way we would detect this is looking in usage mode after deploying a sampling change, and that's not ideal. As mentioned previously, I'd love to use Refinery across all of our services rather than just the high volume ones. And This is more of a feature request and maybe not something that we're going to see immediately, but just if there were real-time sample rate monitoring or alerting in Honeycomb, that would be awesome, because we could proactively alert on that if it got out of spec. And that's it. Thank you for listening. I'm happy to answer any questions you have.
Kevan, what a great tale.
Thank you.
Thank you for that ultimate compliment. It just runs. After it's set up, it's stable. That was really an unexpected pleasure to hear.
Well, we appreciate you giving us stable software.
So there's a question coming from Liz in Pollinators, who is the, as she calls it, the Discuss ARM64 channel in Pollinators Broken Record. Do you consider Graviton 2 for running Refinery for a 40% cost savings with almost no effort?
We did not, but that's a really compelling sales pitch, and it's definitely something I'm going to look into after this.
Oh, great. Yeah, there's more detail in channel there and in blog posts. We've had a lot of fun migrating our services to use the Graviton 2 instances. But you talked about setting up Refinery and the rule-based sampling, and touched a little bit on dynamic sampling. And what was it? What was your path towards winding up at a stable collection of using the rules as a sampling, and what were the trade-offs you walked as you wandered between dynamic and rule-based sampling?
So we started as Refinery beta users, and for anyone who's not familiar, this was essentially the current Refinery, but hosted by Honeycomb and with a nice UI that we could use to make rules. So just from that, we had a pretty good set of rules. Like we knew they were a good fit for our data. We knew they worked for us. That said, we ended up adopting Refinery before the rules-based sampler was actually in the hosted code. So starting with the dynamic sampling was kind of forced by that. Like that was the sampling available to us. And we ended up with a rule set that it did pretty well, but ultimately, like Refinery eventually gained that rules-based sampler back again. And rather than kind of spend more time trying to craft a sampler key configuration and other dynamic sampler configuration that would kind of provide us the sampling we needed while still meeting our business needs, we just chose to port those existing rules that we knew worked to our configuration and kind of run with those. So I feel like we probably didn't get as much bang for the buck out of dynamic sampling as we could have, but it was kind of a decision based on time, based on the people that were available to tune that. Like, better to just go with what we know works.